Hi, this is Richard C. I'm a math tutor at Wyzant, and I'm answering a question submitted by a student. This has to do with matrix algebra. I'm not going to be able to teach you matrix algebra in this short time frame, but I'm just going to solve this problem. But if you don't know how to add and subtract and multiply matrices, you're going to have to review that on your own. So let's get started. We're going to start by taking the system of equations and putting it into a matrix form. So let me just draw a line here. So when you put this into matrix form, you're going to have a 1, 2, 2, 3 times x, y here. Equals 0, negative 2. This works. The reason why this works is if you multiply these this matrix by this one, you're going to get 1 times x plus 2 times y equals 0, and then 2 times x plus 3 times y equals negative 2. We're going to call this matrix A here. We'll just give it a name so we can work with it. And we're told that they want us to solve this using the inverse matrix. There are other ways to solve it, and you could use a variety of different ways. Plus, of course, you could solve this on a calculator. But we're going to do everything by hand here. So let's go after A inverse. Now, there's something called Cramer's rule, which allows you to find A inverse from A. And Cramer's rule says we're going to take 1 over the determinant of the matrix. The determinant of the matrix is is this cross, is like a cross product. It's 3 minus 4. So it's 3 times 1 minus 2 times 2. So it's 3 minus 4. And then you you negate the ones the values on the diagonal. So that's negative 1, negative 3, and you negate them and switch them. Sorry, I forgot to move them. So you swap them and negate them. So you get let's see, I'm sorry. Yeah, excuse me. So you just swap them here. And then the 2 stay as is. They're negated, but they don't move. Okay, so the 3 and the 1 get swapped, and the 2's are negated. Now, this is equal to 3 minus 4 is negative 1, so this whole thing is a negative in front. So I'll just copy this now, negative 2, 1. And I'm just going to distribute that negative 1 through the matrix. So I'm going to get negative 3, 2, and then 2, negative 1. And that is a inverse right there. Okay, so now we can multiply both sides of this equation by A inverse. We're going to get negative 3, 2, 2, negative 1 times A. So this is A inverse here. I'm just reminding you where things are coming from. I'm just going to copy out this equation now. So just 1, 2 2, 3, x, y equals, whatever you do to the left-hand side, you have to do to the right-hand side. It's an equation, so you have to do the very same thing. -3, 2, 2, -1. So you have to multiply A inverse by this matrix here, 0, -2. Okay. So now we're going to get into matrix multiplication. So this is row, first column is going to be this row times this column. So it's -3 plus 4. You see that -3 times 1 is -3, 2 times 2 is 4. So you end up with a 1 here. You're expecting to get the answer of the unit matrix here, and 1, 0, 0, 1, and you do. So -3 times 2 is -6 plus 6 is 0. 2 times 1 is 2, minus 2 is 0. And then 2 times 2 is 4, minus 3 is 1. So there you are, the identity matrix times x, y. I think I called it a unit matrix. I apologize for that. It's called the identity matrix. And now we're going to multiply through here. So it's going to be -3 times 0 is 0. 2 times 2 is 4. And then 2 times 0 is 0. -1 times 2 is -2. And now if you multiply on the left-hand side, you're going to get, I'm going to put it over here, running out of space. I'm going to get xy is equal to 4, -2. This is the way that systems of equations are solved on a computer. And I think once you get to 3 variables, you probably want to do it using matrices. I think with 2 variables, it's probably just fine to solve in the usual way. Let's check our answer. So our solution here is x equals 4 and y equals -2. Let's see if that works. So that would be 4 minus 4, because 2 times -2 is -4. So 4 minus 4 equals 0, so the x is checked. And if y is -2 and x is 4, you're going to have 8 minus, let's see, 2 times 4 is 8. Yes, 8 minus 6. Sorry, I copied that wrong. I have a sign error here. Let's see. This is yeah. I didn't see the negative there. It got squished. So I apologize for that. So it's -3 times -3 times 0 is 0. 2 times -2 is -4. So there's -4 there. And then 2 times 0 is 0. -1 times -2 is +2. So sorry about these signs being messed up. So we have x is equal to -4, sorry, and y is equal to 2. Let's check again. So -4 plus 4 is 0, and then -8 plus 6 is -2. So that checks out fine. And it's my own handwriting does me in more often than not. Okay, so that's it for this problem. So I'm using a lot of fundamentals of matrices, and so you have to know your fundamentals of addition, subtraction, multiplication. And then you have to be able to take a system written in the traditional way and turn it into a matrix equation. And then you need to be able to find the inverse and then solve. So there's a fair amount going on in this one. Okay, that's it for this problem. I'll see you guys again next time. Bye-bye.